Okay.
All right, here we go.
Hi, we'll be getting started in about 2 minutes. Hello, this is Kevin Corson. I'm the Powder Coating Institute's Executive Director, and I'd like to thank you for joining us for the Auto-Deposition Coatings and Powder Coating Applications webinar presented by Steve Edens and Andrew Bias from Henkel Corporation. Before we get started, I would like to remind everyone that all attendees are on mute, so if you have any questions along the way, please type them in the Q&A panel that should be on the right-hand side of your screen. The presenters will address the questions at the end of the webinar. If we run out of time, you will receive a reply via email from the presenters after the webinar. This webinar will be recorded and available on the PCI website within 5 to 7 business days. All attendees will receive a brief survey after the webinar. We appreciate your feedback as we continue to offer a variety of educational programs. Please take a few moments and reply to the survey. Now I'd like to introduce the presenters of today's webinar. Steve Edens is the Business Development Manager with Henkel Corporation and has been in the finishing industry for nearly 30 years. His co-presenter, Andrew Bias, is the Global Specification Application Engineer for Henkel. So Steve, I'll turn it over to you.
Thank you, Kevin. Myself and Andrew will be discussing auto-deposition in regards to powder coating applications. We expect this to be about a 35 to 40-minute presentation with a Q&A, as Kevin just mentioned, and our focus will be on general aspects of auto-deposition, as far as what is auto-deposition, how it works, how it applies to powder coating, and then the benefits of auto-deposition. From an agenda standpoint, we'll discuss a description, the coating process, some applications and approvals, and Andrew will discuss the recent testing he's done, and then some advantages of auto-deposition. Auto-deposition is a chemical coating process where an organic polymeric emulsion is deposited on the surface of a metal substrate. It is similar to other primer technologies, with a few exceptions, the main one being that this is a chemical application and there is no electricity utilized in the process as far as the deposition of the primer layer. Auto-deposition is a relatively green technology when compared to other primer conversion coating technologies. It provides a durable, corrosion-resistant, high-quality coating and can coat full assemblies, including the interiors of tubes and other complex parts. One of the benefits of it, because it's chemical, Faraday cage effect does not apply to it. So coating the inside is a very easy aspect for providing better corrosion resistance. Likewise, because of this, you can also coat full assemblies with some of the auto-deposition technologies. As an example, we have had customers do fully charged gas shocks for automotive applications. Here's an example of a tube that was coated with auto-deposition, 2 different types of technologies, and then 2 different types of Ecoute, and then submitted to salt spray corrosion performance testing. As you can see, the auto-deposition coated the interior completely, where the Ecoute did not. So one of the things with auto-deposition, it coats only the reactive surfaces that it reacts with, which we'll get into in a little bit, but it won't coat things like rubber or plastic, plating, or other items like stainless steel. Also, auto-deposition is not susceptible to issues such as bacteria growth and fungus growth that other similar technologies are. It coats uniformly and essentially has unlimited throw power because a rectifier is not used with this technology. From an edge protection standpoint, there's also a benefit. If you can see these photos, they're showing auto-deposition with a zinc phosphate and E-coated part. The burr sections, as you can see on the bottom section here, with the auto-deposition, the coating follows the contour of the part, including the burr. With the E-coated part, you were seeing a site that there would be some pinhole corrosion from parts if subjected to salt spray. Just a real quick history on auto-deposition. It began as a technology for underhood, underbody components around 1970, and this was the first generation product introduced. This was based off of styrene, and in 75, a second generation came out, which was an acrylic that required a chrome rinse. Once again, the target was underhood, underbody automotive components. Then in 85, the third generation came out, and this was a whole different product here called PVDC. Had a low temp cure and really allowed for complex parts to be processed through it because of the low cure temperature. Once again, though, staying with the underhood, underbody application guide for that. And then in 2005, the fourth generation came out, and this was the epoxy acrylic hybrid. Shortly after this technology came out, it was looked at as a primer layer for a top coat application. Between 2006 and current, 6 other generations have been introduced, and we have been able to successfully top coat the product with powder coat, which we'll discuss in a few slides. But this material's been around for about 50 years, and it is recognized as both a standalone coating and also as a primer layer for powder coating. We'll move on to a description of the process and also the coating itself. The process is pretty straightforward. First, you have to clean the metal, and it depends upon the soils on it. If it is an organic soil, an alkaline cleaner will work. If it does have an oxidation layer, that oxidation needs to be removed, just like any other conversion coating process. But as long as the metal is clean, all you need to do is clean it, rinse it, and as you can see here where it says coat, the auto deposition and the conversion coating are done in one tank. This is a significant difference from other technologies. So you apply your primer coat and your conversion coating in the same bath. The next few slides will show that in a graphic representation. Depending upon the technology used, a seal may be needed, but a seal is not used for all types of auto deposition. And then based on the application, you could be looking at doing a full cure of the auto deposition if it's a standalone product for underhood, underbody, or if you're going to move on, we would do what's called a co-cure if you're looking to apply a top coat to the auto deposition primer. This is the basic reaction that takes place with auto deposition. First, as you can see in the graphic, auto deposition works on steel substrates. It needs a source of iron for this to react. First, you use, in the auto deposition bath, it is an acid. It will etch the steel. Some iron is removed from the part, and the iron forms a complex with the latex in the solution, and then forms back up on the part surface itself. Auto-deposition is a self-limiting reaction. As you can see in this graphic, once it can no longer etch, it can't grow the coating anymore. So it is a self-regulating product. This is an example of a auto-deposition bath, and auto-deposition baths are immersion tanks. So where it wets, it coats, and it can do the inside of a part just as well as the outside. As far as process controls goes for the auto-deposition bath, it's controlled by time, temperature, concentration, and agitation. The graph to the side shows the limiting effects of the growth effects of the auto-deposition layer on the part surface. And it is self-limiting and a very controlled and consistent reaction. If someone was to go on beyond the auto-deposition process and then use a top coat, the only difference here would be that we would change the way that the oven cure is done. To top coat, there would be two ovens utilized. In the first oven, it would really be used to dewater the auto-deposition film. In the second oven, it would be a full cure of the powder coating. We call this the co-cure process. And that is where the powder paint is applied over a partially cured auto-deposition layer. Low temperature in the first oven, and IR is possible there. And then in the powder oven, it will be heated to the required temperature for the powder coat. And the auto-deposition and the powder coating are both cured simultaneously in this oven. This is a representation of the a comparison of the auto-deposition system versus a traditional conversion coating, primer, and top coat system. The one on the left, as you see the parts enter here, would go through the standard conversion coating process, move up, conversion coat, and this is an Ecoute application, primer layer, and then to a full oven to cure the primer, to top coat, which would be powder coat, and then to another cure oven. With auto deposition, a much smaller line is needed, a much smaller oven is needed from the standpoint of dehydration, and then top coat, and then to the co-cure oven. This saves about 40% floor space versus traditional systems. A few applications and some approvals are here on these slides. From an interior standpoint, everything from seat tracks, frames, door components, restraints, shocks, struts, engine mounts. If it's underhood, underbody component, it's pretty much been looked at from an auto deposition standpoint. Exterior wise, small trucks, tractors, outdoor furniture, outdoor equipment, radiators, even electric motor housings have all been coated with auto deposition. This is a very brief list of some approvals, but some of the names you'll recognize: GM, Ford, Chrysler, Hyundai, Volvo, Renault, Mazda, John Deere, Caterpillar, Army Research, Ecoute, and there's a much larger list than this, but these were just some common examples of what we normally see for approvals. We recently began some testing to compare different thicknesses of auto deposition, and Andrew Bias will take over and discuss the testing that he did. Andrew, I just gave you control.
Okay. So what testing was completed? We completed a comparison of epoxy and acrylic auto deposition with TGIC powder cover coating over it. The epoxy and acrylic auto deposition were tested at 3 different film thicknesses, 0.5, 0.8, and 1 mil thickness, and then top coated with a TGIC powder at 2 to 4 mil thickness. dry film thickness. We coated these with a spraymation machine for consistency. They were all painted at the same time and coated to where it wasn't some at 2 and some at 4. And then these panels were tested to 500 and 1,000 hour salt spray, ASTM B117, and then they were rated for scribe creep back. So the process for the epoxy auto deposition that I followed, similar to how to what Steve said, it goes through an alkaline cleaner. These were just standard panels. So it goes through an alkaline cleaner to clean any greases and soils that are on the panels. Goes through a couple of rinses, a city water rinse and an RO rinse. And then it goes through the epoxy auto deposition, which you can see on the right. Those were the times that it took to get those particular film builds. After the epoxy auto deposition, it goes through another RO rinse and then a reaction rinse or a seal, as Steve said. There are 2 oven zones that we followed for this particular product. And the first one, like Steve said, it was a dewatering zone. And the second one is a cure oven. For the acrylic auto deposition, it's the first 4 stages are the same, as we still needed to clean the dirt and soils off of the panels. Goes through some rinses, and then it goes into the acrylic auto deposition. Their time was a little bit more, but those were the times on the right that it took to get to those particular film builds. You can see differences in the 2. You can see a smaller footprint. There is no rinse after the acrylic auto deposition, nor is there a seal or a reaction rinse after. And there is only 1 oven. You don't need a dewatering zone for this particular product. As far as the testing is concerned, at 0.5 mil auto deposition, you can see that 500 hour salt spray, the acrylic and epoxy were similar in results, where at the 1,000 hour salt spray, the acrylic showed better performance over the epoxy auto deposition. Here are the panels. We took 3 panels and then took the average and then graphed them. The epoxy is on the top, the acrylic is on the bottom, 500 hours on the left and 1,000 hours is on the right. You can see for the 500 hour salt spray that there's minimal difference between the 2, so that the panels were very similar in performance, where on the right hand side you can see the difference between the epoxy and acrylic performance creep back on the panels. For the 0.8 mil auto deposition salt spray performance, both the 500 and 1,000 hour salt spray showed that the acrylic did better than the epoxy. The 500 hour didn't do as great as the 1,000 hour, but you see more of a difference in the 1,000 hour than you do the 500 hour. These are the 0.8 mil pictures. You can see a little bit of difference in the 500 hour salt spray. Epoxy did slightly worse than the acrylic. And then on the 1,000 hour salt spray, you can see that the epoxy had greater creep than what the acrylic did. And here is the 1 mil auto deposition. So for this one, the 500 hour salt spray, the epoxy did better than the acrylic. And for the 1,000 hour salt spray, the acrylic did much better than the epoxy. And once again, here are the pictures for those particular, that particular test. The epoxy and acrylic auto deposition at 500 hours, you can see there's minimal difference, but there is a little bit of difference between the acrylic has a little bit more scribe creep back than the epoxy. And you can see the 1,000 hours that the epoxy had quite a bit more scribe creep back than the acrylic. So in summary, the acrylic did much better in most cases than the epoxy when coated with that one particular TGIC powder. We do have testing. This slide shows different testing that has been done with other TGIC powders, and the scribe creep is very minimal, less than 1 millimeter thickness to the scribe creep back. Let's see. And then back to you, Steve.
Thank you, Andrew. I'll just take control again. Just had to make a little adjustment there on my computer. A few advantages of auto deposition. As I mentioned earlier, it's a smaller footprint line, about 40%. Most auto deposition lines are about 6 to 9 stages long, which are considerably smaller than other technologies similar to it. There are fewer variables to monitor in auto deposition. As a coating, auto deposition itself is not limited by, let's say, racking. It is something that where it wets, it coats. So parts can be racked in a relatively dense manner. However, from a powder coat standpoint, you still need to consider that from a top coat. There really is no limitation on part size, shape, or geometry. And parts with threads typically don't need to be masked. There really is no bridging effect with it. Like I mentioned, you can coat fully, full assemblies. Throw power is not a concern. And because it can coat the inside and the outside, inside out corrosion doesn't happen. For example, that trailer hitch there, which is coated with auto deposition, the inside is coated just like the outside is. It provides a uniform coating throughout the part surface and will follow the contour of the base substrate, providing uniform protection throughout. As an example here, and just doing a quick comparison with Ecoute, auto deposition usually is about 30% less in cost between labor, energy, waste, and chemistry. Auto deposition is a sustainable technology and has a very good environmental footprint. The technologies are either very low or no VOCs and contain no HAPs. They have decreased energy consumption, simplified wastewater applications, and a much smaller equipment footprint. So in summary, auto deposition can be used as a primer for powder coat. The conversion coating and primer are applied in a single stage, meaning a smaller system. Auto deposition is a chemical reaction, and other equipment such as rectifiers or other complicated devices aren't needed. It is more environmentally friendly than other technologies that are similar. It provides excellent corrosion performance, superior edge coverage, and interior protection, and overall reduced costs for the process. That concludes our presentation for the day. And this was this was the slide as far as questions, if there are any.
All right, we do have some questions that have been submitted in, so I'll start running through them. First question was, can auto deposition be used for aluminum substrates?
You need a source of iron for this technology. So, okay. At the current time, the answer is no. It needs to have an iron source for it to react.
Okay. What processes require a seal rinse?
Andrew could jump in, but I would say that that would be the epoxy and the PVDC. Is that correct, Andrew?
Yes, you are correct. That's certain chemistries of the auto deposition that need it. So the PVDC and the epoxy are the two that need it. The acrylic doesn't need it.
All right, thank you. Is this, well, we talked about the steel and aluminum extrusion, so that one was answered before. How do you strip off the coating on rejected parts?
It'd be the same as any other primer or paint layer. Substrate would be steel, so you could use an alkaline type stripper application.
Okay. Was there any, or was the testing done with any AMA approved powder on the certified or approved coating line?
I would have to get back to the person that asked that. I believe we did. I would have to confirm that though. And AMA meaning it may be an AMA type paint, however, it would not be on aluminum. Okay.
And question is how is this with castings?
Very good. Castings are it was one of the target markets for some of the earlier technologies.
Okay. Generally, epoxy paints outperform acrylic coatings in a neutral salt spray testing. What do you attribute the opposite ranking with the resins as applied through this auto deposition process?
I will defer to Andrew for that.
Yep. I'm not sure what it was exactly that contributed to the acrylic outperforming the epoxy. That's just the data that we have. We did one particular test with one particular TGIC powder, so it could be different on other powders. But for these particular chemistries, that's the acrylic outperformed.
Okay. Considering that the auto deposition covers edges, there appears in the slides a lot of edge rusting on the panels. Can you explain that?
So for the panels that I coated, the paint was only on the front side of the panels. They weren't painted on both sides of the panels. So there was edge protection, but there wasn't from the paint. So that's why you see a little bit of rust on the edges. It crept from the back of the panels to the edges, and then you see the rust on the sides of the panels.
Okay. What is the bath life for this type of product?
Steve, do you know that one? I don't have that off the top of my head.
It's similar to Ecoute, and what I'd bring up is there are ways to extend the bath life as far as like ion exchange to keep the iron amount down in the bath. I would have to get back to the person that asked the question for a definite number, but the bath life is substantial on the autophoretic tank itself or the auto deposition tank.
There was a question, this is mainly an alternative to Ecoute? Is that the primary?
It's how it was developed originally back in the 1970s, was to compete against Ecoute. That's why a lot of our data looks at Ecoute as the competition for it. However, it is a viable alternative to a traditional, let's say, conversion coating process. That was, and then a primer layer. So yes, it was the initial competitor for it, but things have changed in the past 50 years.
So the auto deposition you consider a conversion coating, but it's really a primer then?
It's both. The conversion coating and the primer is done in the same tank.
Okay. What's the highest film build?
It will self-limit pretty close to 1 mil. I was able to get 1.2. That was in there for quite a bit longer than most processes are going to be run, or it was in there a little bit longer than processes are going to be run. But 1 mil is usually the standard coating.
Okay.
Kevin, I just want to let you know that I just received a message from one of my colleagues about the bath life, and the bath life is pretty much indefinite as long as you can run ion exchange.
Okay, great. Question was, do you ever see setups where the auto deposition line is separate from the powder coating line?
I'm trying. The lines I'm familiar with use the Ecoute process, and in those processes, they are in line. I would have to ask some folks from a tech standpoint regarding that question, because the Ecoute is only a dewatering of flash cure, and that is one of the processes that we have to do that.
Well, I guess the question would be is if you did a full cure of the auto deposition, could it be then primed separately?
The short answer is yes, but we want to evaluate and confirm that on a case-by-case basis.
Okay. Can you discuss any of the personal safety requirements for handling the chemicals?
I would have to pull each sheet up individually, but it is an acid. There are bases involved. And so similar to a standard pre-treatment system, you would have an alkaline cleaning operation, and then the auto deposition tank itself is an acid product. So there would be care with that from that standpoint, but it would need to be discussed on a case-by-case basis.
Okay. What colors are available?
Black is the primary color and has been since day one. However, there have been colors like gray, and it can be pigmented, but black is the standard color.
Yeah. Is auto deposition superior to Ecoute? I'm assuming this is in reference to like a performance.
The parts that, and Kevin, I was going to let Andrew answer that. My system, as I mentioned earlier, starting to tell me I have a connection issue, but the parts are similar. The performance will be similar to Ecoute for the same application.
Okay. How can a coating applicator inspect the coating and successfully that is successfully applied?
I'm not understanding the question.
I think prior to powder coating, how do you know that you've got the right film build and it's adhering properly?
The same as, let's say, Ecoute, the same as any other, as a standard primer.
Okay. What are the startup costs compared to Ecoute?
And would startup, and Kevin, I'm just kind of just from here thinking about this, startup would be from a new system or a conversion of would this be a new install?
I would assume it's a new one if you compared it to that.
Fewer tanks are involved. It's a smaller overall footprint. Based on the size of the oven, you're looking at a smaller system in general. So from a capital standpoint, it would be less. There wouldn't also be equipment like a rectifier needed, a chiller, etc. So I would expect the cost to be lower for the auto deposition coating from an installation standpoint.
Okay. Can you use a hybrid epoxy polyester powder coating on top of the auto deposition? And then do you need a sealant?
I don't see why you couldn't use that type of powder over the top. Obviously, we would want to evaluate it on a case-by-case basis to make sure that it cures properly with the autophoretic or auto deposition.
Okay. What is the functionality, the reactive groups of the acrylic system?
I think we have to get back to that question, Kevin. That's outside my wheelhouse, and
Okay.
I'm not sure if Andrew would have that information. But just to come back to the question about cost from an install,
Right.
it's about 40% less
Okay.
for a direct head-to-head comparison.
All right. Can the coating, I guess, cure at higher temperatures? And I'm assuming if this is a higher temperature powder that needs to be put on it? Or maybe the other way,
Yeah,
is there a limiting
that's the
temperature
way
for it?
There is a limiting temperature for it. I don't know it off the top of my head. They do. They are going to be able to cure in a powder coat oven. Obviously, the oven has to be at elevated temperatures. So for the co-cure process, you're going to have a dewatering zone, and then you're going to have a co-cure process for that to where they can cross-link together. So it will be at a higher temperature. So yes, they are able to cure at a higher temperature.
Okay. The question, and it might be part specific, but it's being asked, how much exact dry film thickness is needed for heavy duty equipment in a primer? But I think you're limited on how thick you can get with a primer, right?
You're only going to get
Yeah.
roughly 1.2 mil max, of 1 to 1.2 as a self-limiting product.
Okay. Let's see where. How good is the corrosion of auto deposition only when you compare it to a top coat, to being top coated with powder? I think they're trying to understand the corrosion capability of the primer by itself.
That's going to depend on the type of, whether it's epoxy, acrylic, or PVDC. That's going to depend on what technology you use. Obviously, it's going to be greater when it is top coated, but it's still substantial and still holds up.
Okay. Any guess on how many systems are installed with this technology?
Steve, do you have a guess on that one?
I don't right now, and I'd have to get back to that person. I'd like to give an accurate number.
Okay. Someone is wanting a little clarification. He did not understand the answer to the edge rusting. Were the panels not immersed?
The panels were immersed. So the edge rusting, they were immersed, they were fully coated. You do have edge protection, but it is going to be, since they were at 0.5, 0.8, and 1 mil, you'll see that the 1 mil is better than it is at the 0.5 mil. You have more coating on there. You have more of a protection for the edges.
Okay.
Hopefully that clarified it.
Okay. Are there any additives?
And Kevin,
oh, go ahead.
Sorry, Kevin. As far as the question about the number of lines, one of my colleagues replied back that there's over 100 lines with this technology.
Okay, great. Are there additives to maintain the efficacy of the auto deposition bath?
Each bath has different additives that are geared to maintain different aspects of the bath once you start it up. So it's similar to like an Ecoute where you have to add pigment and resin. This, you would have to add different chemistries to it in order to maintain the effectiveness of the bath. So yes, there are.
Okay. The next question is will the color change on the substrate after auto deposition coating is applied? And I'm not 100% sure if they're talking, you know, from the liquid to the cured color.
Is this more of like a fading kind of question?
It's not really.
If the question was really about the material specifically as far as UV protection, it would be based on the base resin, acrylic, epoxy, PVDC, the same characteristics that would be seen for other technologies of the same type.
Okay.
I'm not sure if I answered the question, Kevin, but that's the best I can say right now.
All right. Well, we'll ask if someone wants to reply. If they didn't get that question, we'll come back to it. Does the process contain any phosphorus?
I would have to look at the TVBs. I don't believe so.
Okay. Here's a question. Is it difficult to migrate from an Ecoute process to an auto-deposition process?
It's been done before many times, but we'd want to look at each individual application, have one of our specialists come out and look at it.
Okay. Here's, I think, a follow-up to the one. What are the aspects of the different additives for the auto-deposition?
So what they want to know the chemistries of them?
I'm assuming the chemistries or what are you controlling for?
So we control, can you help me out on this one, Steve? I know we control fluoride, we control, I'm trying to think of what the other ones are. There's 3 or 4 different things that we control. So there's fluoride is one of them. I'd have to get back to them on the exact answer as far as what all we control, but we do control quite a few different things on the bath.
All right, and this one sort of, I think it's similar. It's asking what are the levels that need to be maintained with the additives for the auto deposition bath?
That would be different on a product by product basis. Yeah, so depending on whether it's epoxy, acrylic, or PVDC, it's going to be different levels for each, and the TPB would be able to show what levels are needed to create to be able to produce a good coating.
Okay. Is it possible to get auto deposition coating in white or light colors?
We do have a gray.
How light of a gray?
How light of a gray is it, Steve? It's not particularly light.
Well, there is a gray, and it would have to be looked at for the application because in other regions, they are looking at other regions, meaning other regions of the world, they are looking at different pigmented products.
Okay. All right. This is maybe a follow-up, and I think you may have touched on it, but can you retrofit existing metal finishing processes, or is a new equipment required for the auto deposition process? Probably a lot depends on what's existing.
It does, and it has been done before where we've retrofitted existing systems. And really, if there's interest in that, we'd want to have a specialist come in and look at the actual line in the application. But we have done it before.
Okay. Any negatives to the technology?
Do you have any, Steve?
It's a primer coat on the part, Kevin, and I'm not aware of any negatives. It works as a very good primer or base coat, and from an advantage standpoint, it would really be a smaller footprint than similar chemistries such as Ecoute.
Okay. How does the steel composition affect deposition efficiency, the time to build, to get to the film build, specifically when multiple steel sources are utilized? Will that impact the quality of the deposited film?
That I would have to get back to them. I'm not 100% positive, but like we have stated, it needs a source of ferric, needs a source of steel in the bath. So as long as it has steel, it should coat and should coat well.
Okay.
And Kevin, that may be one of the biggest negatives to the process, is that it's steel only, or a ferrous alloy only.
Okay. That's a good point. Is there any criteria for determining what coating weight is recommended?
Coating weight. Go ahead, Andrew. Sorry.
You don't measure this by coating weight, since it is a primer layer. You measure it by thickness. So it would be on a case-by-case basis how much you would need, depending on what powder you're using, depending on whether you're co-curing the process. That would determine how much you would need to put down for a primer layer.
Okay. Do you need to control the bath temperature at anything above or below ambient, or is there a temperature range you got to keep it in?
The 68 to 72, you have to keep it in.
That's Fahrenheit, right?
Yes, Fahrenheit.
Yes.
So 68 to 70 Fahrenheit, you have to keep it in, and it's a pretty tight range, I know, but that's where it coats the best at.
So if you're in a hot area, you have to have a cooling system for it?
It would be a small chiller or a cooling system for it. I would say I don't believe the bath itself is exothermic in the reaction, but you would want to be able to control the temperature, and especially if ambient temperature is hot, like the southern states, that might be more of a concern.
Okay. What is the pH of the auto deposition bath, and is there a flash off time needed after that before you get to the dehydration?
I don't know the pH off the top of my head. I would have to look up on the MSDS or actually see an actual bath and put a pH probe in it. So I don't know the pH of the actual bath, but it is on the acidic side. It is lower. As far as flash off, it can go right into an oven. It doesn't need to flash off. Certain applications do need a dewatering zone, so that would be considered your flash. You'd have a lower temperature just to dewater the film, and then it would go into a cure oven past that.
Okay.
As far as a pH goes of the actual bath, approximately 3. Similar to a zinc phosphate tank.
Okay, great, super. All right, that's the last of the questions that I have that have come in. I would ask if you have any other comments that either Andrew or Steve you would like to make.
Thank you for the opportunity to present.
Yeah,
okay. Thank you. Steve, can you flip the next slide there? Thank you. At this time, that sort of concludes our webinar that we have on here. I'd like both thank Steve and Andrew for their time and effort put into here. I just want to remind everybody to watch for a survey. We do appreciate the feedback on it. And for those of you, if you had issues hearing or seeing this, there will be a recording that will be on the PCI website. Probably in about 5 to 7 days. So again, thank you for joining PCI on here. Don't forget to save the date for the Powder Coating Week 2021 in Orlando. which will be starting on February 23rd through the 26th. And I'd like to thank everybody. Have a great rest of your day. Bye now.